Hello everyone, welcome back to Edexcel Science channel. And now we are at question 18 from 2026 June IAL Chemistry Unit 2 paper from Edexcel. So this question is about halogens and halide ions. When chlorine reacts with sodium hydroxide, the products depend on the conditions. Write the equation for the reaction between chlorine and cold aqueous sodium hydroxide. State symbols are not required. So this is from topic 3, the disproportionation reactions of halogens when they react with alkali. You have to remember that if they're reacting with cold aqueous alkali, then they will produce halate 1 ions, which is basically XO minus ion. And if they are reacting with hot and concentrated, then they will produce halate 5 ions. On top of that, even though this is not related to this question, when the halate 1 is formed in this reaction, if you heat it, if you apply thermal energy, it will disproportionately break down to form halate 5 ions again. Okay. So in this case, the reaction is very simple. You just have to memorize all of this. So chlorine will react with sodium hydroxide and form a salt, okay, added with the halate 1 ion, which is NaOCl, or and there will also be water. Okay, you can actually write it as NaClO, which is also fine. That's totally up to you. Now, the equation for the reaction between chlorine and concentrated um, hot concentrated aqueous sodium hydroxide is shown. Okay, so as we can see, when chlorine reacts with hot and concentrated alkali, it produces the same salt and water, but the halate ion is different. Now this is halate 5 ion. Explain in terms of oxidation numbers what is meant by disproportionation using this reaction as an example. So guys, what is disproportionation reaction? Disproportionation reaction is basically when a single reactant is both reduced and oxidized. Okay, the same reactant will go through reduction and oxidation. If you notice over here, if you notice over here, chlorine in the beginning, when it's in its uh, elemental form, will have an oxidation number of 0. Here, chlorine is -1. So it has been reduced. But if you check the halate 5 ion, chlorine over here is +5. You might be wondering how I found it out. Since it is called halate 5 ion, it basically means that the halogen inside this has an oxidation number of 5. If you do not remember this, you can use the algebra method. So let's consider chlorine as X. We know that sodium is always going to be +1 and oxygen is always going to be -2. So we can use that. So 1 plus X plus 3 times -2, and overall it has a charge of 0. So X is equals to +5. That is another way to do it. Okay. So now I have to explain that chlorine has been uh, both oxidized, I'm using short forms, and reduced. Okay, actually, let me write it separately. So chlorine has been oxidized from 0 to -1 in NaCl. You have to mention the compounds, okay? Otherwise, you won't score that mark. it has also been reduced from 0 to positive 5. Um, Actually, no, sorry, I wrote it the other way. Oxidized from 0 to positive 5, actually. Yeah, positive 5 in NaClO, and it has been reduced from 0 to negative 1 in NaCl. Sorry, I wrote it the other way around. And that is how you explain this proportionation reaction. You just have to show that it has been reduced and oxidized. Moving on, number B. When bromine reacts with sodium hydroxide, a compound is formed that contains sodium, bromine, and oxygen. The percentage by mass of sodium is 15.3% and bromine is 52.9%. Calculate the empirical formula of this compound. So let's make 3 different columns. So sodium, bromine, and oxygen, right? But I do not actually know the percentage composition of oxygen. So we can just subtract it from 100, right? So percentage of oxygen is 100 minus 15.3 minus 52.9, which will give us 31.8%. So this is 31.8. Now, what I am going to do is I'm going to find out their moles. So I'm going to divide it by their relative atomic mass. I don't think I'll have enough space, but let's see. That is going to give me 0.665, 0.662, and 1.985. 987 actually, yeah. Now, what I am going to do is I'm going to check that among the moles of the atoms, which one is the smallest. So this one is the smallest, and I will divide all of them by that number, by the smallest moles. Okay, if I do that, this will become approximately 1, this will also become 1, and this will become 3. So my empirical formula is NaBrO3. This is also a halate 5 ion because the bromine has an oxidation number of 5. I always tell my students to memorize all this information because that is the best way to score marks in chemistry. Now, when concentrated sulfuric acid is added to solid sodium iodide, several reaction occurs. Yes, that is true. The reaction occurs in 3-4 steps because the iodide ion has so much reducing power that it will reduce sulfuric acid to um, to a sulfur dioxide, and then to I think sulfur, and then to hydrogen sulfide. So it happens in multiple steps, and it is the most reducive halogen we have. Okay, so reaction 1. Sodium iodide reacts with concentrated sulfuric acid to form a salt and a hydrogen halide. State how the iodine ion reacts in this reaction. You always have to remember that the iodine ion in the metal halide will always react as a base. Okay. Reaction 2. Hydrogen ion reacts further to produce iodine and a gas with a bad egg smell. This is hydrogen sulfide. Okay. It has a rotten egg smell or a bad egg smell. Identify the classification of this type of reaction. This is a redox reaction, okay? Because in all of these reactions, right? In this reaction and this reaction and the other one which produces sulfur dioxide, all of them are redox reaction. Why? Because both oxidation and reduction are taking place simultaneously. Now, the final question from 18. In another reaction, hydrogen iodide produces iodine and a yellow solid. Um, write a balanced equation for this. This yellow solid, okay, this yellow solid is the sulfur, okay. So I can just say I can use this information that, okay, hydrogen iodide reacts with sulfuric acid to produce iodine, this yellow solid, which is sulfur, and always um, water. Okay, it will produce water. It doesn't produce it in the first reaction, but in the uh, next reactions, next reducing reactions, it will produce water. Okay, and we also have to balance this. I always tell my students to memorize some of the balancing, because in the exam, if you do the balancing manually, it's going to consume a lot of time. Okay, so I hope question number 18 is clear, and I'll see you in the next video.